In this lesson, you will know and use the formulas for the areas of parallelograms, triangles, and rhombuses. So remember, a parallelogram, by definition, is a quadrilateral that has two pair of parallel sides, such as this picture. And in this picture, we are given the bottom, or the base, to be 3 inches, and the height, which is the perpendicular distance, is 2 inches. And the question is to find the area of this parallelogram. Well, in the last lesson, we learned how to find the area of a rectangle. The area of a rectangle was the base times the height. Now, notice if we were to shift the parallelogram to get this rectangle. So the left and the right side, we kind of shift to the left to make it squared up, so now we have a rectangle. Well, now we have a 3 by 2 rectangle. And notice that this would be the same formula for the parallelogram as we would a rectangle. If we just shift this over, we get this new rectangle, and we know how to find the area of a rectangle. Rectangle is base times height. So the parallelogram formula is actually the same as a rectangle. We take the base of 3 inches times the height of 2 inches, which would give me an area of 6 square inches. The only thing to be careful of is with the height that you are taking the actual height and not the slanted height. Okay, the height is the perpendicular distance from the top to the bottom. So this should be a 90-degree angle. Whereas if you were given the length of this third side over here to be maybe something like 1.5 inches, if that were the case, then you would not even worry about that because that is not the height. This is a slanted height. We're concerned about the perpendicular height. This is 2 inches. So take note of that. Just be careful when you deal with this formula that you're getting the actual height and not the slanted height. Next, we're going to work with triangles. The area of a triangle is 1/2 of a rectangle, or 1/2 of a parallelogram. Notice if I were to draw another triangle on the top of that first triangle that's identical to the first, we now have 2 identical triangles. And here we have a picture of a rectangle. Rectangle we know how to find the area of. The area of a rectangle is base times height. But notice this triangle is 1/2 of that. So the formula for the area of a triangle is 1/2 of the base times the height. So here we have 1/2 of 12. 1/2 times 12 times 9. So 1/2 times 12 is 6. 6 times 9 is 54. So the area is 54 inches squared. Here's another triangle that is not a right triangle, but the formula is still the same. Because if I were to imagine drawing a second triangle identical to this and putting it up on the top like that. Now we have 2 triangles that create a parallelogram. The area of a parallelogram we know is base times height. Well, the area of this triangle is 1/2 of that because we have 1/2 of that parallelogram. So same idea, area for this triangle is still 1/2 base times height, where the base is the bottom, which is 12 inches, and the height is the distance from the vertex down to that base. So it's perpendicular, it's a 90-degree angle right there. So the 9 inches would be the height, 12 inches the base. Plug those numbers in, and you're going to get 54 square inches. Now, 2 quick things with this picture. First off, once again, be careful with the height. The height should always be perpendicular. So it's perpendicular to the base and not the slanted height. Okay, so make sure that those 2 things are true, that you're not dealing with a slanted height, and also that the height is actually the perpendicular line from the vertex to the base. The next shape we have is a rhombus. Now, a rhombus is a specific type of parallelogram. So we can still use the parallelogram formula, which is base times height. So the base and the height will be perpendicular to each other, and the height is connecting the 2 sides. So here we see 10 inches would be your height because it is perpendicular to the top and the bottom. So 10 inches is your height, and then 12 inches down here would be your base. So just plug those numbers in. You have 1/2, or sorry, not 1/2, but you have 12 times 10, which gives you 120 inches squared. So same formula applies, But there is a second formula that we can use as well. And the second formula uses the diagonals. So here we see two diagonals. Now with the rhombus, we've learned before that the diagonals do two things. One is they will create 90-degree angle here in the center, if this is a rhombus, as well as it will cut the diagonals in half, meaning CB, if this were the first diagonal. So CB were the first diagonal, then from C to the center here would be 1/2 of that first diagonal, and the other part would be also 1/2. So this diagonal is cut in half by the other diagonal. And if the other diagonal is, we call D2 for diagonal 2, same thing, this one is also cut in half. So we have, here is 1/2 of D2, and down here is another half of D2. So here we have this labeled with 1/2 D1 and 1/2 D2, meaning 1/2 diagonal 1 and 1/2 diagonal 2. Now I'm going to show you where the formula comes from here. So notice that we have 4 right triangles, and the right angle is here in the center for each of them. So looking at just one of the triangles, maybe let's look at the one right here on the right side. So this triangle right here. So trying to find this area of this triangle, what I can do is I can take my triangle formula, which is going to be 1/2 base times height. Well, the base is 1/2 D2, the height is 1/2 D1. So I take 1/2 times the base, which is D1, and the height is D2, or vice versa. So here what I have is going to be 1/2 times 1/2 times 1/2, which gives me 1/8 D1 D2. So that is the area of one triangle, but notice each 4 of those triangles are identical. So looking at all 4 triangles put together, we have 4 times 1/8 D1 D2. Well, 4 times 1/8 would give you 1/2. So what we have is 1/2 D1 D2. And this is another formula that we can use. So for example, if we know the length of AD was 8 inches, and then the length of BC were 10 inches, then the area of this rhombus would be 1/2 D1 times D2. So 1/2 times 8 times 10. So the area would be 40 square inches. And that concludes our lesson for today. We will see you next time.